All right, guys, so today we're going to be talking about circular motion. So last class period, we kind of got into the period of a pendulum, the frequency of a pendulum, and we are going to be able to apply that to what we're using today, because circles move in a very similar fashion. They make cycles, they go around in circle, and so we're going to apply that idea of a period to some circular fashion. So, two definitions we have here. We've got centrifugal force and centripetal force. Now, centrifugal force, you're going to want to write this down. Centrifugal force is the apparent outward force caused by circular motion. Now, centrifugal force doesn't actually exist. That's why it's apparent. It feels like it's there, but it doesn't actually exist. Think about those carnival rides that have you sit along the outer edge and the object starts spinning and then they drop the floor out, but you're still stuck to the edge. It feels like you're being pushed out toward the edge. However, you're not actually being pushed out toward the edge. And we'll talk about why that is in a little bit. And then the second one we have here is the centripetal force. They sound very similar, but they're very different. The centripetal force is the inward force caused by circular motion. Now, this is the one that actually exists. So as an object is going forward, we have an acceleration toward the center of a circle that causes the object to go in a circular fashion. So that's that centripetal force, that inward force caused by circular motion. So we know already that acceleration means to speed up, slow down, or here, most importantly, it means to change direction. All rotating objects are going to be accelerating. So if you look at this picture here, you've got the long lines going perpendicular, so that would be like this one here, 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 and here. Those show our linear motion. So the object in a linear fashion has a velocity in that direction. But the object, the smaller arrows that you see is actually the object's acceleration. You see they're at a right angle, right here, 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 and here. The acceleration is at a right angle to the velocity. So that's going to cause that object to turn. And that is a type of changing direction. So all rotating objects are going to change direction, and that's what causes them to go in a circular fashion. So here, when we talk about time, it's going to be the total time. We know frequency is the number of spins in a second. So when we're talking about a circular fashion, it's always going to be how many times the object is rotating or spinning or oscillating. We kind of talked about the word oscillating last time. And then the period is the time needed for one spin or rotation or cycle or oscillation. So remember, those are inversions of each other. So remember, if we look back at our formulas, we remember that frequency is 1 over our period, and our period is 1 over our frequency. So they are inversions of each other. So if we know that a car has 3,000 RPM, and actually let's bring this out a little bit bigger. Oh. So our car with 3,000 RPM, that means rotations per minute. So that's rotations per minute. this is going to be the same as cycles per minute or circles per minute. So that is cycles per unit of time. Now, we know that there are 60 seconds in a minute, so we will end up using 60 seconds as our time. So this is equal to 1 minute. So if we know that there are 3,000 rotations, so 3,000 cycles in 60 seconds, so cycles per unit of time, 3,000 divided by 60, that gives us 50 hertz. So it's going 50 times around in circles per second. Then if we invert that, because we know period is the inversion of that, t equals 1 over f, or 1 over 50, that gives us our period of 0.2 seconds. So that's how we can get all those numbers there. Once you get your frequency, you invert it to get your period. Or, once you have your period, you can invert it to get your frequency. So, here are all of our formulas today. The first two that are starred, we've already talked about. So that's your frequency. And here you've got events over time. That is the exact same as cycles over time. And then your period is time over events. That's the same as time over cycles. So that's that one there. The last three are going to be brand new. So we've got this one here is going to be our velocity formula for a circle. Now this is a little bit different than our velocity formulas that we have used before. So what we've got here is velocity equals 2 times pi, so that's that 3.14 number, 2 times pi times the radius of the circle divided by our period. And remember, the radius of a circle is from the center to one of the edges. So we don't want to use the diameter there, we want to use the radius. Most of the time, the question is going to give you the radius and not the diameter. However, just make sure every time that you are using the radius for that type of problem. So that's our velocity. The next one here is our centripetal acceleration. And we have the velocity that we just looked at, so this one here, squared divided by that radius again. So it's just v squared divided by our radius. So in order to use that acceleration problem, you're going to need to know your velocity. So we're going to have some multi-step processes here. And then lastly, here we have our centripetal force equation. Here we need to know our mass times our acceleration. And here we have another piece that we're going to have to add from our last question. So centripetal acceleration goes into that force equation. So here we've got a multi-step process. You may need to use all three of those. You may just need to use one. You may even have to use those first two equations that we learned last time and have a 4-step problem. Just know that you need to figure out what you're looking for and work backwards from there. But it's always going to be kind of a linear process here. So here's all your units. You can pause for a second if you want to write those down. So we're going to jump into a couple of problems. I want to work through these with you. So in this one, it says a 1.5 kilogram ball spins 3 times in a circle that is 0.6 meters in radius every 6 seconds. Find the linear speed. So let's go ahead and open this up a little bit. I'm going to move that over to the side. All right. So, a 1.5 kilogram ball, that is a mass. Oh. All right, there we go. Got that in a good spot. So, our 1.5 kilogram ball, that's a mass. Spins 3 times, so that's going to be how many cycles? So 3 cycles. And we have a circle that's 0.6 meter radius. So radius is 0.6 meters. And this is gonna happen every 6 seconds. So 6 seconds. We want to find the linear speed. So first thing we're going to do is look and find the equation that gives us linear speed. So that's going to be this one here. Okay? So we'll just kind of underline that. That's where we need to get to. So in order to use that equation, we are going to need a couple of things. Get a good color here so you guys can see. So we need our period and we need our radius. So we already have our radius. Our radius is here, but we're gonna have to find our period, and that's this here. Okay, so in order to find our period, we're going to use time over events. So that's going to be time over our number of cycles. So 6 seconds over 3 cycles gives us a period of 2 seconds. So that gives us, this number here is our t. Right? So we've already calculated that first time. Now we're going to have to put that into our next equation. So here we had step 1. Oop. Actually going back, this was step 1. And then this one is going to be step 2. So now we're going to take V and set that equal to 2 pi r over t. So 2 times pi times our radius, which gave us 0.6 meters. And then we're going to divide that by our period that we just figured was 2 seconds. So when I put that in my calculator, I'm going to put 2 times, and then I'm going to hit second, and then I'm going to hit the little caret button. You want to find the pi on your calculator. It's located on the right side of your calculator, and it's in blue color. So you're going to have to hit second, and then press that button. So 2 times pi times 0.6, and then you're going to hit divide, and then 2, and then send. And that comes out to 1.88, and that's going to be in meters per second. And that is our linear speed. So that's our final answer here. So we started at the end, and we figured out what we need, what formula we need to end on. And that was our formula right here. So we found our formula, and then we worked backwards from it. So you always want to work backwards from that final formula to find out what exactly you need to know. All right, and this is going to be our last example problem. So what is the radius of a ball spinning 15 meters per second with a period of 0.5 seconds? So let's write down what we know first. So the ball is spinning at 15 meters per second, so that's a velocity. Ooh, let's get that. There we go. So 15 meters per second, that's our V, with a period of 0.5 seconds. So that's our lowercase t. Okay, and we want to know what is the radius of that ball. So if we have V, so that's here, we have that one as well, and we have period, so that shows up here and here, and we want to know radius. We need to look at which formula has both V and T in it and will help us solve for radius. So let's look at that. We've got this one here has time and events in it, so that's not going to help us. So we can't use that one. This one doesn't. The F formula here has nothing helpful in it, so we're not going to use that one. The centripetal acceleration formula has V in it, and it has R. However, we don't know that, we don't know this centripetal acceleration, so that's not going to be helpful to us either. And then our final one down at the bottom, we've got F equals ma. That's not going to be helpful either. So we know we're going to use V equals 2 pi r over t, and we want to solve for r. So we need to move this equation around a little bit to get r by itself. So we're going to take V equals 2 pi r over t. We want r by itself, so we need to multiply both sides by t. So those will cancel. So we have t times V equals 2 pi r. And now we need 2 and pi to move over, so we're going to divide both sides by 2 pi. So that both of these will cancel. So our radius ends up being t times V over 2 pi. So writing that all out, we've got 0.5 seconds. Let's get that. There we go. 0.5 seconds as our period times our velocity of 15 meters per second, all divided by 2 pi. Now remember, when you put this in your calculator, make sure you have that parentheses there so your calculator doesn't get confused. You want to treat it like it's an idiot, because it will do exactly what you say. So make sure you have those parentheses. So I'm going to put into my calculator, and you can follow along with me just to make sure you have this right. I'm going to put button by button 0.5, then I'm going to press the multiplication button, and then 1/5, so that's the top, then divide, and then open parentheses, and then 2 times, and then I'm going to hit the second button and put that pi in there again, and then I'm going to close that parentheses. And then I can press enter. And that comes out to a radius of 1.19 meters. And that's the entire problem. So on your worksheet, there may be problems where you are given very little information. You may have to find, let's go back a second. So you may have to find your t so that you can plug that into your velocity formula, so that you can plug that into your acceleration formula, and then plug that into your force formula. So just make sure you start from the end and work your way back to the beginning.